Imagine using AI every day to search through massive amounts of data, only for it to completely forget everything by the next day. Today, we're going to put an end to this inefficient personal RAG architecture and look at how former OpenAI co-founder Andrej Karpathy makes knowledge truly grow. This is the most counterintuitive finding in this research. With LLMs supporting ultra-long contexts of over 1 million tokens, traditional RAG Retrieval-Augmented Generation is actually obsolete for personal and small team scenarios. We no longer need to make AI search for a needle in a haystack of massive documents every time. Instead, to understand this shift, we first need to grasp. Let me give you a concrete example. Prompt engineering is like going to a coffee shop and racking your brain to describe the exact ratio of latte you want to the barista. Context engineering? It's designing the perfect kitchen for the barista. You don't need to teach them how to make it every time. As long as the tools and ingredients in the environment are right, they will naturally. If you don't manage your context, AI will exhibit these 4 symptoms of failure. For instance, it might suddenly start talking nonsense or get derailed by an irrelevant piece of web text. This is exactly why we need to systematically filter and organize information, rather than blindly dumping every PDF into the LLM. To solve these failure issues, context engineering relies on 4 core actions: write, select, compress, and isolate. This is essentially an optimization system for information load. Remember, you aren't just chatting with a bot, you're managing a dynamic system of knowledge. So, who took this theory to its ultimate practical application? It's the LLM Wiki architecture proposed by Andrej Karpathy. This architecture fundamentally revolutionizes how we handle personal knowledge management. This quote is crucial. In the past, we took notes ourselves and used AI to polish them, but in Karpathy's method, the roles are reversed. Humans become directors who only point the way, while the LLM becomes a tireless compiler, automatically compiling your messy resources into a structured Wikipedia. The physical structure of this system is actually very simple, just 3 folders. The human drops raw materials into the raw folder, and the LLM, following the rules in the schema, automatically digests and refines the data, then writes it into the wiki folder. This 3-tier structure guarantees absolute data safety and automated system operation. You might be wondering what a schema looks like. It's actually just a simple markdown file, perhaps named clau.md. You write down rules in natural language in this file: what to do when encountering a new concept, what to do with a conflict. The LLM will always read this file before it starts working to ensure the knowledge base it organizes always aligns with your personal habits. To ensure you, the human director, can maintain control at all times, the LLM doesn't just write articles, it also maintains a global map called index and a work log called log. With a quick glance at the log, you'll know exactly what books the AI read for you last night, what new knowledge it discovered, and which entries it modified. Before we move on to the next section, let's do a quick test. Where do you think a new report should go? Think about it, then tell me the answer. Ready? If you guess correctly, it means you've grasped the concept of an immutable source of truth. All knowledge must go through compilation. If you didn't get it right, no worries. That's exactly the automated pipeline we are going to break down next. So the data is in. How does the magic happen next? This brings us to the core of how this system operates, the 6-stage pipeline. This is the entire process of bringing knowledge to life. From collecting data to LLM compilation, you browse it in the front-end software, ask it questions, save the valuable answers back, and finally perform regular health checks. Let's expand on a few of the most critical steps. A traditional cloud drive just stores files, but here, ingestion is an active compilation process. The LLM acts like a tireless assistant. It not only reads it for you, but also dismantles the data points and stitches them into your existing knowledge network. It'll even tell you, hey, this new report conflicts with our data from last month. The questioning phase is even more interesting. You aren't searching for a needle in a haystack across thousands of raw PDFs. You are asking questions to a highly concentrated, already refined wiki. If you ask a brilliant question and the AI provides a fantastic comprehensive analysis, that answer gets saved directly as a new article. This is the compounding mechanism of knowledge. Just like code needs debugging, knowledge needs health checks. The LLM regularly runs linting operations, essentially a health checkup. It will locate those isolated, unlinked nodes or automatically search the web to fill in any knowledge gaps you've left behind. This maintenance work costs humans almost zero effort. Of course, to allow the LLM to smoothly read massive amounts of data, there's an unavoidable technical challenge at the foundational level: chunking strategy. This is also the key differentiator between an average user and an advanced architect. Imagine you want to feed a thick manual to an AI. You can't just stuff it all into its processing pipeline at once. You have to cut it into smaller chunks. But if you crudely cut it strictly by word count, you'll likely sever crucial context, leading to disjointed information. That's why we need smarter chunking strategies. Here are a few advanced strategies. Take late chunking, for example. It reads through the entire text first to establish a global understanding before chunking the details. It's an absolute game changer for reading complex legal contracts. And the most advanced is agentic chunking, which lets the AI decide for itself how a document should be sliced. This is where the true depth of context engineering lies. Ready? Let's do a quick recap of the pipeline we just saw. Which step is responsible for cleaning up unlinked, isolated nodes? Locking your answer. That's right, it's the health check phase, linting. Now that we understand this pipeline and the underlying tech, let's see why it absolutely crushes traditional RAG. Many people will ask, isn't this just RAG? Actually, it's completely different. For individuals and small teams, this method holds an overwhelming advantage. The biggest issue with traditional RAG is that it's basically read and destroy. You ask a question, it searches the data, and the next time you ask, it has to search all over again. But the wiki model solidifies that knowledge. Plus, since LLMs now support over 1 million tokens, we can just stuff the entire wiki into the context at once, avoiding any retrieval loss and achieving perfect recall. Implementing this architecture doesn't require expensive enterprise software. Karpathy's recommended tool stack is incredibly minimalist. Use Obsidian as your visual front end, a web clipper to grab web pages, QMDev for local searches, and finally Git to version. Control your knowledge base. Everything stays on your local machine, fully secure and controllable. So, what can this personal knowledge operating system actually do in the real world? Let's look at 2 specific scenarios. For research or deep reading, this is practically a cheat code. You throw in dozens of papers, and the AI automatically extracts the core concepts for you, linking together viewpoints on the same topic across different papers. You aren't just passively reading, you're making AI help you build a knowledge universe that you can summon at any time. In a business environment, the value of this system is even greater. You can throw all the dormant meeting minutes and chat logs in your company at it and let it automatically generate an internal wiki. Or collect scattered news about competitors and let AI piece together their complete product roadmap for you. That is true intelligence analysis. Let's quickly summarize the 4 hardcore concepts covered today. Context engineering, which is replacing prompt engineering. The mental model of treating AI as a compiler. Late chunking technology to solve long. Text slicing, and the linting mechanism that allows your knowledge base to self-purify. If you only remember one thing today, make it this. Traditional AI search makes you rediscover what you already know every time, leaving you running in place. A compiled knowledge base, however, lets your knowledge snowball and continuously accumulate. This is the compound interest engine that widens the cognitive gap between people. So, stop obsessing every day over how to write the perfect prompt and stop babysitting the AI. Go set up your folders, write down your first set of rules, and let the LLM truly become your personal knowledge compiler. Stop searching, start compiling.